Handy dandy PowerShell ISE open. And what I'm going to be demoing to you now is how many of you are familiar with internal monologue? Okay, so internal monologue is essentially a offensive tool that allows you to get the current user's net NTLM v2 hash from doing an RPC call to LSASS. That's I butchered that explanation. You should probably take a look at the GitHub repo that explains it in detail. Elad Shamir did an awesome write-up on how this actually works, so you should probably take a look at that as well. So what I'm going to be doing is I'm embedding the internal monologue DLL, which is a .NET assembly, okay, in an IronPython script, okay? I'm then taking that IronPython script, embedding that into PowerShell, and then I'm invoking IronPython from PowerShell and executing the IronPython script. So that's exactly what I'm going to be showing you. And again, this is all possible because all of these languages and all of these techniques are based upon C# and the .NET. So they're all interoperable with each other. So it doesn't matter what language you choose, as long as it's a .NET language, you can embed it within PowerShell, you can embed it in anything you want. Okay? So this is the internal monologue DLL. This is just some really badly written code that decompresses the DLL and unbase64s it. We then call assembly.load, which is that magic function that I just talked to you about, which loads it directly into memory. And then we can literally from then on just call the namespaces that we defined within that internal monologue DLL and then execute the actual internal monologue attack. Okay? And these are the 4 DLLs that I just told you about. So we got the IronPython DLL, the Microsoft Scripting, Microsoft Dynamic, IronPython. Those get automatically loaded when PowerShell executes the script. And then down here, we do engine.execute, which takes that IronPython code that I just showed you and actually executes it through PowerShell. All right, you're all with me so far? Okay, sweet. So we execute this. And there you go. So we've executed the PowerShell script, we then executed IronPython, which then executed the internal monologue DLL. And this is my current user's net NTLM v2 hash. One thing to note about this particular attack, if you were admin, it can actually downgrade. It can perform like a downgrade attack. So if I were admin here and I executed this, I would have gotten an NTLM v1 hash, which I can then submit to services like crack.sh, which basically have created rainbow tables for DES, and you'll automatically instantly get the clear text password for that hash, which I think is really, really cool. All right? So that's just one example of, and just bear with me because it's going to get weirder. That's just one example of embedding payloads within one another, right? So let's talk about Boolang now. Because by far, Boolang, in my opinion, is the most useful of these languages for offensive purposes. For mostly a couple of reasons. One, their documentation is awesome, which is very rare to find in these languages. IronPython is not as well documented as Boolang, and considering nobody has ever heard about Boolang before, that is amazing. You can find it at that link at GitHub. And the reason why I like it so much, too, is because it's basically like if Python and C# had a baby. And that's Boolang. So it's heavily inspired by Python syntax. And you can do basically, you can just call C#.NET APIs directly through Boolang. And this is an example code. Hopefully you can all read that. If not, I'll be showing it to you bigger in the demo that I got. So hopefully you all read that. But in this example code, what we're doing is we're calling the mini dump write dump function, which allows us to dump memory. And specifically, we're dumping the LSASS process here. So we're manually dumping memory of the LSASS process through the mini dump write dump function, which is a native function that you can use to dump memory. And then you can take that dump file and then parse it offline with Mimikatz to get clear text credentials from that. Okay? So this is a perfect example of how to weaponize this stuff. The best part about Boolang, and this is a really, really big deal, is that it can call native functions, but those native functions are all truly in memory. Okay, so like for example, if you called add type in PowerShell, it will leave artifacts on disks. Not with Boolang. If you call native functions with Boolang, everything is done in memory, everything is truly in memory, and you can still call native functions. So this is the equivalent of basically compiling C# through Roslyn, if you're familiar with that. Roslyn is a way of dynamically compiling C# and accessing it on the fly. This is the equivalent of doing it with Roslyn, only that it's in Python, and, well, somewhat Python, so like a hybrid. And it's a scripting language, which is, in my mind, it's a sort of big deal. So again, you can get these examples, some of the demos that I'm about to show you from that one repo. Under runboo.cs, which is the C# version, so we're embedding Boolang and C# in that one. And then invoke jumpscare.ps1, I thought that was kind of cute because, you know, boo, invoke jumpscare. Yeah, okay. Only me, I guess. Okay. And then we're embedding boo into PowerShell, and then we're going to, in this particular case, in this demo I'm going to show you now, we're injecting shellcode through boo to pop calc, because we all got to pop calc. And also, okay. Boo requires 3 .NET assemblies to run. So you got boolang.dll, boolang.compiler.dll, boolang.parser.dll. So this is like where my knowledge of this is a part of this. I still don't completely understand how this is possible, but technically, Boolang requires those 3 as assemblies. But when you compile it through the actual compiler, which I'm going to be talking to you about in a second, it doesn't need those. I'm not exactly sure why, but if you embed it, it does require those. If you compile it, it doesn't. And it doesn't embed the DLLs, doesn't do anything like that because I disassembled it. I'm not exactly sure why this works, but that's just something to know. And it's a very important thing to know because there's other implications to that when I'm talking about in a second. So in PowerShell, you literally just call assembly.load on those 3 DLLs, and that's all you really need to do to embed Boolang in PowerShell. And in C#, you could just hook the assembly.resolve event, and then at that point, your world's your oyster. So I'm going to be demoing a Boolang payload right now. Let's see here. Okay, so this closed on me. Okay, fine. I'm going to go over here, go into here. PowerShell window. Oh boy, okay. Properties. Make this huge. Okay. So I got my invoke jumpscare script here. I'm going to import that into my PowerShell session. And actually, before I do that, let's take a look at the code here so we're completely understanding what I'm doing. Invoke jumpscare. Okay. So we got our 3 DLLs, the Boolang DLLs. This is just shellcode that I got from MSF Venom, which pops calc. It's pretty straightforward. Once we load those 3 DLLs, we then have access to the Boolang compiler. It does compile stuff. It's an engine, but they call it Boolang compiler. So that's just, you'll find that too. Like the terminology varies from language to language. So in this particular case, I am executing Boolang code from a separate file on disk, right? But you don't even need to do that. You can actually embed, like the IronPython example that I just showed you, the Boolang code within PowerShell itself. And then you just, a couple of statements here that just says, hey, I want to compile it in memory. Don't do anything on disk. And then you run the assembly, and then you call the main function of the Boolang code, which executes the actual shell code. Okay? So let's do that real quick. Invokes jumpscare, and then you should pass it, if I recall correctly. Just nothing. Okay, wait. Let's just try that. Compiling, executing, and then there's calc down here, and there you go. So you can see from the output here, like it took the Boolang source code, compiled it, executed it, injected it in memory using one of the, there's like 3 shellcode injection methods in that one Boolang file, which we can actually take a look at. real quick so you can see that it's actually pretty similar to what you'd expect from Python. Let's do that real quick. And there you go. So we just defined a class. This is all Boolang, a Boolang class. We import all of the native methods that we need to inject shellcode. This isn't using it like the QUser, EPC, if you're familiar with that. That's one method of injecting shellcode. Then we got the inject self, and then we got the inject remote. So depending on what method you want to inject, you can choose one of those. And again, like you don't need to have this on a separate file. You can just embed it in the PowerShell script itself. So I think that's pretty cool, and it's also really weird. Sweet. And again, let's just as a reminder, the reason why we're doing this in the first place is because there is no insight into the .NET framework, right? There's no way of hooking into, with like exception of a couple of things like ETW, hooking into the .NET framework to view all of this dynamic code that's being run. Okay, so you can take the power of PowerShell, embed it with another language, and just get around all of that. Usually, it really is as straightforward as that, as of right now at least. So ClearScript. ClearScript is a fun one. I actually discovered this last month, and it's an official Microsoft project. So ClearScript is literally made, from the description, it literally is made to add scripting capabilities to your .NET program. Okay? So what's very interesting about this, though, is that you can call JScript and VBScript from ClearScript, if that makes sense. So by default on Windows, you can access JScript and VScript from PowerShell. You can do it through Windows script hosting. But using ClearScript, for some reason, it seems like it's not doing any of that, and it uses its own runtime to parse JScript and VBScript. What that means is that Windows Defender, for example, at least from what I understand about it, as of right now, and from what I've seen, is not able to detect like the squibbly do attack. If you're familiar with that, subt's work, basically you're downloading an SCT file using JScript. It is not able to detect any of that because there are no hooks in place right now in order for AMZ to actually get in there and inspect what you're doing through embedded JScript, through ClearScript. Okay? It also supports the V8 high-performance JavaScript engine, which is also really interesting. But it needs a lot more assemblies for that. And this is like an example of some C# code that you can use to embed ClearScript within C#, and we're just calling like wscript.shell ActiveX objects wscript.shell, which will execute a command. And I'm going to be demoing a ClearScript PowerShell payload right now that basically downloads a squibbly do file, SCT file, okay? And loads that in memory and pops Notepad so that you get an idea of like the capabilities of this thing. What's really interesting though is that you can expose the entire CLR to JScript using this way. So what that means is that you can now call native functions from GScript through ClearScript, if that makes sense. And there's a lot of power from if I do get that working one day, there's a lot of power there because that would be as if you had like a .NET to JS. For any of the red teamers that know what .NET to JS is, it's basically a way of calling C# from JScript. And usually we use something from James Forshaw, which implemented this tool that allows you to do that. But with this method, you would be using like a Microsoft utility to go about doing that, which would sort of be, I think, a big deal. I'm not exactly sure if I'm thinking about this right, but it's still an interesting way of going about it. So I'm just going to demo that real quick. Wrong one, but OK. Hold on. All right, so I got my little HTTP server up here. I'm going to go back to my PowerShell ISE script, go to invoke ClearScript. So we're embedding, you download ClearScript. Again, this is all open source. Download ClearScript, compile it, embed it, load the assembly, and then you have access to this ClearScript engine. You can also call VBScript from ClearScript. In this case, I'm just using JScript. The words are flying, I know. And we're calling getObject, which allows us to download that payload, which I'm hosting on a HTTP server. And this hopefully won't trigger AMSI. And there you go. Pop notepad. And just to give you an idea, so like, okay, so that's doing it this way, right? What happens if I tried doing that just straight up with PowerShell? What would happen then? There's no way I'm typing that out live, so I copy and pasting this. And there you go. Malicious script has been blocked by your antivirus software. So by going, like sort of by embedding ClearScript within PowerShell, we get around AMSI, but if we just straight up call JScript from PowerShell and downloaded that file, it gets blocked by the AV. So this is where I'm trying to go with this, right? So we're sort of operational, we're trying to get around like the operational downsides of using C# tradecraft and going back to using PowerShell, only not executing our malicious code with PowerShell, but with an embedded language, if that makes sense. All right, now let's go back to the presentation. And also, how much time do I have left? Okay. All right, I'm going to try to go somewhat fast, okay? So these are all of the .NET languages, third-party .NET languages that I am aware of as of right now. And there's some really interesting ones. So if you like coding in Lua, for example, Moon, Sharp, and Lua are your friend because you can embed the Lua programming language within PowerShell, for example, if you wanted to. Jint is another GitHub project that allows you to embed JavaScript within PowerShell. What's really interesting, and this is something I've not experimented with yet, so I'll leave this as an exercise to you because I don't know what will happen. I'm assuming it won't work, but it would be really interesting to see what would happen if you threw a beef hook at an embedded JavaScript runtime in PowerShell. I'm assuming it would break because it's not a browser, but it still would be interesting. It would be an interesting thing to experiment with, like the concept of beefing endpoints. I think it is interesting. .NET WebAssembly, this is something I'm going to be keeping a close eye on, allows you to execute web assemblies in memory through .NET. How crazy is that? Yeah, don't even ask how this works because I have no clue. And yeah, web assemblies in general, I think, is going to be an interesting thing going forward from a red team perspective because I still have to read up on it, on how everything works there, but I think it's going to be, there's a lot of shenanigans that you could probably pull with some web assemblies. ClearScript, JScript, VBScript, and JavaScript, so if you want to embed those languages, ClearScript is also something that you can use. IronPython 2, Python 2. There's IronPython 3, which is still being worked on. Do not use it yet because it's not stable at all. But Python, you can embed Python 3 once that gets stable in .NET. There's also Ruby. Whenever you want to embed Ruby, there you go. And then Boolang. Boolang is by far, though, I think the most useful out of all of these, as of right now. So here's something I've never talked about before publicly. These languages come built in with a compiler. So usually all these languages have a standalone compiler. What that means is that you can take any script and just compile it directly through the compiler that they provide, and then you can take that compiled code, like compile executable, and run it everywhere. And it doesn't matter what .NET version is installed, it'll just run everywhere because it compiles it in intermediate language code, which means it'll just run .NET 2, .NET 4.0. It'll just run everywhere. So this is by far the easiest way to compile and run your .NET code. And okay, I'm going to demo this for you real quick. So like if you don't want to embed stuff and just want to weaponize a real quick Boolang script that you wrote, this is the way to do it. This is probably the way to do it because you don't have to deal with the DLLs. You don't have to deal with embedding, with the resolving the DLLs at runtime. It's just pretty simple. So I have my mini dump code here, which I showed you before, okay? And this dumps LSAS memory, okay? Straight up, just calls mini dump write up and just dumps LSAS memory to a file on disk, right? So what I'm going to be doing real quick is I'm going to be modifying this in order to get it to compile. So I'm going to make this a static function and that's going to be the compiler's entry point because that's just how Boolang works. I also have to actually call that function somewhere, and I'm going to give it the arguments that we pass on the command line, right? So when this gets executed, it'll go into the main function. The main function is going to receive the arguments that we pass to it. And over here, I am just going to say, hey, the main function needs to accept the arguments as a string array. Pretty simple. And then down here, I am going to say, hey, I want you to take the first argument and use that as the dump file name. It's pretty simple, right? So we now have our code. Let's go over to the folder where I have Boolang. I'm going to open the PowerShell window here, and it's perfect. That's awesome. And now I am going to use the Boolang compiler, which is not BooIC, but is booc.exe. And if you take a look at the help menu here, you'll see that it has a lot of interesting options. One of them is you can embed entire directories. You can embed arbitrary data. You can also select the platform to compile to. And those are pretty much all the interesting functions that I would say. Oh, and you can also set the target file. So if you wanted to compile to a WinExe or an exe or like a DLL, you can do that through the compiler as well. So I'm going to specify .o, and I'm going to say the compiled output should be memdump.exe. And then I'm going to give it the path to my code that I just got, that I just modified here. If I remember where it is, desktop. And then minidump p.boo. And there you go. That's a warning. It's fine. Ignore that. That's just because I'm bad at coding. And we have memdom.exe ready to go. So there you go. So that's our compiled executable from Boolang code, right? So I just want to point this out. Like, if you had to do this with C#, it would take a lot more time to do this with C#. Because I just edited something through Sublime Text as opposed to installing Visual Studio, getting familiar with Visual Studio, getting familiar with C#, and then getting this ready. So it's a lot faster and easier, and it allows you to write really quick payloads on the fly that'll just run everywhere. And just to give you an idea that this works, I guess, okay, let's do it this way. Let's run PowerShell as admin because I need that to dump memory. Did I run it as admin? No, I run it as admin. Perfect. Okay. All right, we have our memdump program here, and we're going to give it converge. Perfect. Dump to converge.dump, and if we go to C, the C folder here, you can see that we have our memory dump down here, 40 megabytes, which is pretty standard for memory dump. So there you go. So we've dumped memory using Boolang, which is this is a lot faster than going through Visual Studio and doing all of that in C#. And again, if you take that and run it on a Windows 7 machine, it'll work too, because it is not embedded. You've compiled it through the standalone compile, and it'll work everywhere. Okay, so weaponizing Boolang. Let me check the time here, because I would have... okay, I'm pushing it. I don't think I'll have time to demo this for you now, but Silent Trinity is a project that I've written that tries to weaponize a lot of these concepts. So this is the C2 framework that I've built, and it essentially, right now it uses Boolang and IronPython, a combination of both, in order to actually run code in memory, and there's a bunch of modules that would be interesting. Like, if you do check it out, there's a Mimikatz module, which is pretty crazy because it basically runs Mimikatz through an embedded IronPython engine, which is embedded in PowerShell. And then there's another stager that uses the MS build whitelisting technique, if you're familiar with that. So that's embedding C# within an MS build file, which is embedding IronPython, which is then running Mimikatz. It's pretty crazy, and it works surprisingly well. So definitely check that out. I've recently released, like a few months ago, an update for it. It's gotten from the beerware stage to alpha, so like things actually work now, which is good. All the C2 comms are encrypted using elliptic curve Diffie-Hellman key exchange with HMAC. So it's pretty solid on the crypto side now. It also has Boolang support, so that allows us to call native methods directly from the actual C2 framework, which is really good. So we can take screenshots, we can dump memory, we can do all of the stuff that I just showed you right now, right? Also, tab completes everything, and you can customize the check-in interval, and there's now a help menu function, which, that comes in handy. So let's talk about detection a bit. Probably the best way to go about detecting this is upgrading to .NET 4.8. I think recently it came out of beta, if I recall correctly. So you can actually probably put this in production right now. The problem is anything less than .NET 4.8 does not have AMSI integration. And .NET 4.5 is installed on every Windows 10 machine in existence. So unless you manually update all of your endpoints.NET version, you're not going to have the AMSI hooks necessary for it to try to detect this kind of stuff. And again, this is AMSI, right? So it's signature-based detection for the most part. So you have to take that with a sort of a grain of salt as well in terms of like detecting this. There's also a bunch of projects which have come out, thankfully, to actually try to get data on all of this C# tradecraft, and which would allow you to detect some of this stuff as well. So there's like collect.NET events for manifestation, which is like proof of concept PowerShell code that you can use to detect ETW logs, which is basically the only known way, I think, that would allow you to collect this type of information. There's also Crabs ETW, which is an official Microsoft project. It's this C++ wrapper on ETW, but it's sort of like, it's a wrapper, so you'd have to actually build your own tool. There's that. Silk EDW has come out recently from FireEye, which is a really good option. It's by far, I think, the most usable detection mechanism out there right now. Module Monitor by a friend of mine, the Wover, he's got some really cool stuff. He recently released Donut, which is essentially a way of taking a .NET assembly and turning that into shellcode, which is really, really interesting. You should check that out when you have a chance. But he also has another thing called Module Monitor, which allows you to get the data from ETW itself and see what's being loaded into this current the process that is running CLR, the actual .NET runtime. So there's ways around that. There's also this awesome talk by Luke Jennings at Black Hat 18. Memory resident implant code injections is alive as well. That's an awesome resource. And Countercept actually released a blog about hunting for Silent Trinity. So like they put together a bunch of detections that you could probably use in your environment right now to detect the Silent Trinity framework that I released. So there's that as well. And big thanks to Cobber.io that compiled a lot of these resources as well. But by far, I think like the best way to go about detecting this stuff is ETW logs and upgrading your .NET version. That is, I think, at least from my knowledge right now, that is by far the best way. Also, a really dead giveaway is, so if you're not familiar with Process Explorer, Sysinternal's Process Explorer, it actually allows you to monitor assemblies loaded in current .NET processes, right? So this is the app domain of a Silent Trinity stager that's running in memory. You can clearly see, that's fancy, isn't it? Okay. You can clearly see that the Boolang assemblies and the IronPython assemblies are, first of all, there, but also they don't have an image backing. So that means that they've been loaded in memory. So I think that is by far like a really good giveaway in terms of just like C# tradecraft in general. I'm not exactly sure if there is a way of detecting if current loaded assemblies don't have an image backing on disk, but this is by far a dead giveaway. And also, like, Silent Trinity. That's pretty obvious. But I think, like, in terms of detecting this stuff, this is probably a really good way because I'm not a .NET developer, so I can't really speak to this. But I'm not exactly aware of a lot of .NET programs that actually load stuff from memory. So this should not be a behavior that you commonly see. So I think that might be a pretty solid detection mechanism by itself. Also, I'm in the middle of a complete rewrite of the tool because I hate myself. So basically, I'm going to be writing this thing from scratch. It's going to be team server based. So if you're familiar with Cobalt Strike, it's going to be using WebSockets. It's going to be multi-server, multi-client support. It's going to be using WebSockets for real-time communication between the server and the client. It's going to have a lot more comms. I actually have domain DNS or HTTP working as a communication method for the C2 implant, which I think is really cool. Also WMI. So if you're on an internal pen test, WMI comes in handy as a C2 mechanism where like they firewall their endpoints or they don't allow HTTP traffic. So I got that and domain DNS over HTTPS, 80% there. Long-term goal is to integrate a bunch of other tools that I've written over the years so that you have a single tool that can manage your infrastructure and that you can manage your internal pen tests with. I think that would be a really cool thing to have. So you'd have Red Baron and CrackMap exec that would be integrated within this tool, and you'd use it as a single tool to manage everything. Internal credentials, internal spraying credentials, infrastructure deployment for red teams. That is the long-term goal. That is the pipe dream. We'll see how far I get it to go that way. And also Empire Metasploit compatibility would be really cool if I get a time around it. And also some of the SpectreOps stuff that they released recently, I'd love to get that to work through the Silent Trinity team server at least. That would be interesting to see if I can get that going. And also support for more languages, because it's really cool that you can just embed whatever language you want, right? So if your friend writes a Lua post-exploitation script for some reason, you can just use that within this framework and you're good to go. You have a friend that writes Ruby, perfect. Embed, compromise the endpoint with a Ruby Silent Trinity agent, and you can run Ruby scripts that do all the post-exploitation stuff we all know and love, and you can pillage all the things. Questions? All righty. Okay, thank you.